Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and you are at video 3 or 4 or 5. No, I'm joking. Video 4, if I'm not mistaken. In this series of videos forming part of the Winter School for Junior Tikkies, proudly supported by Investing. When we talk about the sequences and series sum, and the specific sum about sequences and series, which is now question number 2 of November 2021, the final exam paper. I'm again not just going to work through it, but I'm going to talk you through it first of all. Let's look at this question 2. Actually not a difficult question, but I'm going to ask you first, try it yourself, and then watch the rest of this video. When we talk about this, I'm again going to refer back to my formula sheet first and foremost. So going back to my formula sheet tells me that I have these formulas to choose from. Geometric series specifically are those bottom ones there, those 3. Remember those. So let's just, before we actually answer the question, let's just quickly talk through question 2.1, 2.2, and 2.3. Question 2.1, calculate x. Now the moment that I hear calculate x, I'll go to definition. The definition of a geometric series is what? T2 over T1 equal to T3 over T2. Once I get that, I can substitute in, and I'm going to solve. But let's wait a bit with that now. Question 2.2, they're asking, show that Sn. So I know I've got to go to my formula. Then in 2.3, they're talking about the sum to infinity. S infinity, A over 1 minus R. Let's just go for it. Let's just go for it. Let's start by looking at the first question, 2.1. I went to the definition, T2 over T1 equal to T3 over T2. Now I know a lot of you guys cross multiply, so I'm going to do that as well. So after I've simplified that 81 over 90, I cross multiply and solve for x. Now please, ladies and gentlemen, please don't just go to the next question. Write in what you've got from the x equal to 100. If I put that x equal to 100, I now have the series 100, 90, and 81, which means A is 100 and R is 90 over 100 or 9 over 10. Now this I can use in question 2.2 and question 2.3. Simple and straightforward. Let's look now at question 2.2. Remember what you've got. Because it says Sn, I'm going to go to the normal formula from the formula sheet. But I'm going to do a sneaky, a dirty little school trick that I've learned a long time ago. I can, with a minus, swap around both top and bottom. So both numerator and denominator. I can swap around, and then I have that kind of a formula. Now you might ask me, Sorrel, why on earth would you as Mr. VG go and do that? Well, let me share. Look at where you want to go. I want to go to a place where I say 1 minus something. So that's why I am looking rather at 1 minus r to the n instead of r to the n minus 1. That's a bit of a sneaky, but I love it and you can learn it. But you have to swap both numerator and denominator. So when I look at this next up, I'm just going to substitute the values for A and R in, and I'm going to now simplify by calculating that 100 over 0,1. What I love is comparing this to where I want to go. I've got the 1 there. I've got the 0,9 to the n. And what is the 100 over 0.1? Yes, it is the 1000 that I'm looking for. Yes, I've got it. Now they say hence or otherwise. Calculate the sum to infinity. I'm going to choose to do the or otherwise. And they say I can. So I'm going to use the formula for S infinity. A over 1 minus R. A is 100 and R is 0,9, which means I've got 100 over 1 minus 0.9, which gives you 1000. Easy, easy claps. But now I've got a question for you. How would I solve this if I tried to do it using the word hence? In other words, what did I have previously? What would I do? What would I do? What would I do? Well, let me share this with you. What I could do is if I look at Sn being 1000, 1 minus 0,9 to the power of n. If I take my n, and now I'm not going to write it very mathematically, okay? Because if I have to write it very mathematically, I would have to introduce limits. You know those beautiful things you did in calculus that a lot of teachers just brush over? But what happens as n goes to infinity? In other words, 0.9 to the 1. Let's put it in our calculators. Okay? 0,9 to the 1. Well, that's just 0,9. What if I change the 1? Ooh, that's my eraser is a bit too big. What if I change the 1 and I make it a 2? Well, that becomes 0,81. What if I change the n into 3? Well, that becomes 0,729. What happens slowly but slowly but slowly? As I make this larger and larger and larger. So in other words, what if I make this 1,000 to the power of even 10? That's going to be like 0,00 something. Okay, let me put it in my calculator quickly. 0.9 to the power of 10. That's not 0,0. Oh my. But it's 0,34. Dot, dot, dot. I hope you start seeing what's happening. Slowly but surely, this 0,9, as n goes bigger and bigger and bigger, as that n goes towards infinity, this tends to go to the number 0. So in other words, S infinity is going to go towards 1 minus 0. Now, where does the 0 come from? Because that whole back part, the 0,9, goes towards 0, which means this S infinity is going to go towards 1000. Oh, Oh, sir, whoa, that's the same answer we got from doing S infinity. I know. That's the beauty behind this. Now, if you didn't understand what I mean by the 0.5 to the power of n, please relax. You can use the formula. That's fine. I'm just having fun. So if you get that, if you understand that the 0.9 goes to 0 as I make the powers larger and larger and larger, then you would see that S infinity goes towards 1000. Now, please, if you are a math teacher and you look at my notation and you start cringing, because I know that I can't really say 0.9 to the power of infinity, but it's just for explanatory purposes. That's just for explaining. So I don't want to confuse students by writing all the fancy maths, but it's for understanding. So, ladies and gents, please go and just think about maths as you're doing it. And have a wonderful rest of your day. Tune in to the next video where we are going to look at question 3. This is Sarah van Grinnen, aka Mr. VG, signing out. Keep well. Cheers.